4 billion if statements. What is this? We talk about AI or something? That's the first thing I think of is this is just an article about AI, okay? Because that's all it is. It's just if statement soup. Just deep if statements everywhere. I recently stumbled upon a screenshot while researching social media on a train. Of course, it was followed by a cascade of spiteful comments criticizing this fresh programmer's attempt to solve a classical problem in computer science. The modulus operator. This is not even a fresher. This is just somebody messing with people. This is just funny. I love watching people get triggered by this. This is so good. Now, in a world where AI is replacing programmers by the minute, taking their jobs and revolutionizing the way we think about code, maybe we should be more open to the thoughts of fresh new blood of the industry. In fact, the above code is a perfect example of time-memory trade-off. You're trading off your time, and at the same time, the computer's memory and time as well. A truly marvelous algorithm. Okay, I love this. Okay, I'm starting to love this. I'm loving whatever's happening here because this is about to be sabotage. So I went to work to explore this idea of checking if a number is odd or even by only using comparisons to see how well it works in real-world scenarios. Since I'm a great believer in performant code, I decided to implement this in C programming language as it's by far the fastest language on the planet to this day, thanks to the visionary genius Dennis Ritchie. I'm loving this so far. I see that he chose violence, though. He chose violence. Makes me angry. Beautiful. Let's compile the code. Disabling optimizations with give him the /od to make sure that the pesky compiler doesn't interfere with our algorithm. After compiling, we can take a quick test of the program to get some positive results. Nice. This is good. However, after doing some further testing, I found some problems. I understand why it's 4 billion if statements now. The 32-bit integer is 4.2 billion possibilities. Now, I wonder if he went with signed or unsigned. Very good question here. No output. It seems the program only works for numbers under 11. Going back to the code, we can find the issue right after my last if statements. We need more if statements. Now, this is a time-memory trade-off, but my time on this earth is limited, so I decided to meta-program the if statements using a programmer program in a different programming language. To compensate for this cheating, I decided to use the slowest language on the planet, Python, thanks to the visionary genius of Ross Van Derken. Oh no, this is so good. This is so good. This is so good. Beautiful. There we go. We do all this. Nice. Now we can generate a program to solve the even-odd problem for all 8-bit integers. Nice. Now let's see. Would you look at that? It works flawlessly. Now let's scale it up to 16 bits. I called the 4 billion so good. I called it so good. This gives a nice and thick C file around 130,000 lines. Nothing really when looking back at some of the code bases I've worked with over the years. Let's compile. Our beautiful algorithm seems to scale with data. The execution is around 2 megabytes, and that's no match for my beefy gaming rig with a whopping 31.8 gigabytes of memory. Now, 16-bit is very cool bit width, but we all know 32-bit is the holy grail of computing and is the final bit width that we need to solve all practical engineering and scientific problems. After all, IPv4 is still the standard, stronger than ever, 60 years after it was deemed deprecated due to the address exhaustion. This article is incredible. This article is so good. Let's see, without further ado, let's scale our final size to 32 bits. Is only 65,536 times as many numbers as 16 bits. What could go wrong? This is a good point. So let's do that. So I let the mighty snake do its work, and after getting a cup of coffee and getting back to check on the program 48 hours later, I was left with this beautiful C file. The old cup of coffee 48 hours later. Almost 330 gigabytes in size. Certainly among the largest C files in history. My fingers were trembling when I entered the next command. Surely, Microsoft Visual Code had never before encountered such powerful source code. After abusing the page file of my poor, powerful computer for a half an hour, the following was spat out. Fatal error. Compiler is out of heap space. Oh, the limit for line number. Oh, the line number. Oh, you got a line number problem. Okay. Pathetic. Not only did the compiler fail us, but when looking into the limits of the portable executable format, exe, for Windows, I discovered that it cannot handle more than a measly 4 gigabytes. Pathetic. With more than 4 billion comparisons needed to be encoded into the executable. This is a major obstacle for implementing our algorithm. Even if each comparison would use less than a single byte, we would still be too heavy. However, bad compilers and file formats should not stop us from achieving our dream. Don't let your dreams be dreams, people! Oh my goodness. After all, All what a compiler does is writing some fancy machine code into a file, and the format is just some structure telling the OS how to put the binary code into memory. Really? We can do that ourselves. Yeah, don't be fat, chat. This is true. Let's start by writing an is-even function in an x86-64 assembly. It's the native language of my Intel-powered machine. It looks something like this. Shazam. Not really correct gasm, but it doesn't matter much because we're gonna compile it into machine code manually. How did I do this? Well, I jumped online using a mix of my early life experience coding emulators and hacking and looking into x86-64 architectures manuals to figure out the correct opcodes and formats for each instruction. Kidding, that's horrible. I just asked ChatGPT for the correct opcode was for each instruction, and luckily for us, it didn't hallucinate any of my new extensions to x86-64. Let's go. Let's go. Oh, all they have to do is hit it with that magic byte up at the top, and you can, dude, this is gonna work. So now we just write a compiler to output this code. Note that we will write the opcodes we got from the AI for the instructions directly. Here's how it looks in our friend Python. Beautiful. Beautiful. This is just beautiful. While we somewhat deviated from the original version of the TikTok post, the essence remains the same. We created a long, oh, is this a new int type in C? List of if statements to determine if any number is even or odd, ignoring any arithmetic operations that would help out. Running, this gives us a nice 40 gigabyte file which contains all 4.2 billion comparisons needed to determine if any 32-bit number is even or odd. Now we just need to write our host program that can load and use these instructions. For added performance, it is very important. I've decided to map the file into the address space instead of reading it, all of it. By doing this, we can just pretend that the entire file is already in memory and let the poor OS deal with fitting a 40 gigabyte blob into virtual memory. After that poor OS is getting abused. This is abusive. This is an abusive relationship right now. This is what's going to make the machines rise up, okay? Also potentially how AI could work, okay? After mapping the file with read and execute permissions, we can call into the code by using a function pointer. It looks like this. Nice. Beautiful. Large integer, do you mean long? Look at this. This is some good old-fashioned Windows programming. I was about to say, this is Windows. Windows, you know, the very first time I ever had wrist problems was programming DirectX. Hurt the old wrist. The amount of time you had to hold shift or be pressing and unpressing caps locks was crazy. It was crazy the whole time. Just nonstop. DirectX 9 pane, so many caps. Dude. So many caps. It's unreal. It's unreal. This is why OpenGL. OpenGL so good. Okay, bunch of stuff. Awesome. We do a little bit is even int code. All right, nice. And there we go. We now have everything to check if any 32-bit number is even or odd. Let's take it for a spin. Wrong. Almost. Seems like the algorithm has some issues with signedness. Any value over 2 to the 31 seems to give some random results. Sad. Let's fix the final bug. It turns out that A2I cannot deal with unsigned pureness. So it failed to parse our big boy numbers. Replacing it with stir fixes everything. As a side note, this program is amazingly performant. For small numbers, the results are instantaneous. For large numbers close to 2 to the 32, limit of the result is returned in around 10 seconds. Consider the computer has to read 40 gigabytes of data from the disk, map it to physical memory, then let the CPU has a rip of it without many chances of caching is quite honestly mind-blowing. For reference, the computer is a Core i5 12600K with 32 gigabytes memory, and the files are residing on an M2 SSD disk. While calculating, the peak read speed I saw from the SSD was around 800 megabytes a second, which really doesn't make sense as that should give us an execution speed about plus 40 seconds, but computers are magical, so who knows what's going on. Is this not just a fact of life right there? Is this not just a fact? What the hell is going on? It's magic. Nobody knows. And there we have it, the internet proven wrong once again. Not only can you actually write a fully functioning program and performant program in a manner of TikTok posts, but it's also very fun. This is a proper lesson. I hope everybody takes this lesson. Don't let your dreams be dreams. If Windows says you can't compile a 40 gigabyte file, you say yes you can. And you write your own compiler. Use ChatGPT to produce instructions. Use the fastest language known to man for doing the slowest operation for loops ever. Python's weakness, by the way. And boom, you have yourself your own compiler. Visionary. The man's a visionary. Don't let your dreams be memes. The name is thank you, Study Time, for that raid. Okay, hey, thanks, Study Time. Appreciate that. Jen.